Welcome. The purpose of this video is to give you my method for solving this challenging limit. This limit is indeed challenging because here we have infinity minus infinity, and here we have 1 minus 1. So we have an indeterminate form 0 over 0. So to solve this indetermination, we need to factor both the numerator and the denominator. For the denominator, we have an algebraic identity and we can handle it easily. But for the numerator, the situation is more complicated and we need a trick in order to factor this quantity. So you can try to do the computation by yourself, and if you find another method different from what I will give you now, you can share it in the comment. The hint here, we will use this algebraic identity. A power n minus b power n is equal to a minus b, the sum from 1 to n minus 1, a power k, b power n minus 1 minus k. So I give you this hint, and it's what we will use in order to factor the numerator. So let's start. We start by factoring the denominator. Here we have an algebraic identity a power 4 minus 1, which we can see as a power 2 minus 1 and use the remarkable identity. So we get a square minus 1, a square plus 1. And now we can use another algebraic identity to expand this quantity. So we get here 1 plus 2 over n power 2 over 3, 1 over n power 2 over 3 square minus 1. Here 1 minus 1 cancel, and finally we get this relation. So now we will let the denominator in this form, because we have here n power something, which will cancel when we compute the numerator. These two quantities, this one goes to 2 when n goes to infinity, and this one goes to 2 also when n goes to infinity. So this quantity we need to let it in this form. Now so we have this we have done with the denominator. Now we tackle the numerator. So first we write we make n plus 1 power 1 over 3 as a factor, and we get this quantity. Now we can also expand this quantity to get something of the form 1 over something. So we get this. So we write n minus 1 as n plus 1 minus 2, and we expand to get 1 minus 2 over n plus 1. and we get this quantity. So now we can factor here by n to get n power 1 over 3 factor this quantity, and now all the difficulty lies in this quantity. So we need to work on this quantity, and see it is the tricky part of this computation. So let's go. Now we will tackle this quantity. So we have this expression of the numerator. Now we remark this 1 power 3 minus this quantity power 3. If you take this quantity power 3, you get 3 over 3 here, and you get this equality, which simplifies to get 2 over n plus 1. Now we have here a power 3 minus b power 3, and we will use our algebraic identity. A power 3 minus b power 3 equal to e minus b factor a square plus ab plus b square. And we get that this quantity, which is a here is 1 and b is this quantity, we get this is a minus b square, a square at power 3 minus b power 3, 2 over n1, we will get this quantity, factor this quantity. So if we have just used this algebraic identity by taking a equal to 1 and b equal to 1 minus 2 over n plus 1 power 1 over 3. And we get, now we have done, because now we can compute this quantity. This quantity is just this one over this one. And what is interesting, because when n goes to infinity, here the limit is 3, and there is no problem. So now we can replace this by this one over this one, and I think that it's the tricky part of this computation. And what we get this for the numerator, we get this expression where q is this quantity. We have this 1 over q, and we get this. Okay, now we have the denominator we have, it can be written as 1 over n power 2 over 3 q1, where q1 is this quantity. And finally we get that n over d is n power 1 3, and here we will get 1 3 plus 2 over 3, which is equal to 1, and this quantity, and here 1 over q1, and we have almost done. So finally we get that our sequence is equal to this expression, and we need when we take the limit, this one goes to 1, this one is easy, and here q and q1, here is q1, are given by this quantity. Q goes to 3, Q1 goes to 4 when n goes to infinity, and when the limit of 2n over n plus 1, we can cancel n in both the numerator and denominator and get the limit equal to 2. And we have down, so finally we get that our limit is equal 1 over 6, and we have down. Okay, thank you, and to support the channel, please like, subscribe and share, and thank you.